Hello, class. Good day. So, this is the discussion of the first lesson of the module 1, the nature and uses of mathematics. And in this lesson, you must be able to describe the nature of mathematics, differentiate between invented and discovered mathematical concepts, and identify at least three practical uses of mathematics in real life context. So, just a short introduction about our topic. So, mathematics is more than just numbers and equations. It is a language that helps us understand the world. So, I already discussed this from the first week of our class. So, from the ancient times to the present, math has served as a tool for discovery, innovation, and daily problem solving. So, in this lesson, you students will explore the philosophical and practical aspects of mathematics, examining whether it is something we discover like a law of nature or invent like a game, and how math is used in real life contexts such as finance and technology and the nature. So this activity, hindi niyo na ito gagawin because it is already done. So let us go directly now to the discussion of the first lesson. So first is the nature of mathematics. So the question here is mathematics invented or discovered? So most students are they're possibly not yet in a position to answer this question because it takes time and exposure to mathematics to answer it with some confidence. So no, dili ta makaingon dayon nga you as a regular student ay kuan na mathematics invented siya, ay discovered siya. So the mathematics education students receive from schools is the proverbial tip of an iceberg, meaning for example, me, I studied mathematics or Bachelor of Science in secondary education, major in mathematics. So those lessons know that we have discussed during my college years. Kato siyang mga lessons no nga gidiscuss namo is it's just a tip of the iceberg. Kung kakita mo, as you can see here in the picture, the tip of the iceberg, di ba, in a sea level. So kanang nasa taas dara mo na siya ang tip. So di ba kung tan-aw na to iyang kabuuan, gamay lang kaayo siya nga portion sa kinatibuk-an sa iceberg. So in mathematics ato ang knowledge no about mathematics is just a tip of an iceberg. So, also majuning mathematics. So, mathematics no is a finished product of a huge collection of knowledge, which is hundreds or thousands of years in the making. So, most students, you are unaware no of the processes that gave rise to the mathematics education that you have received. In addition, the structure of mathematical knowledge itself is often hidden to students and is likely to remain so for the rest of their stay in school. Kaya naman, sa tuang subject karon mathematics in the modern world, broad kayo ang concept sa mathematics class, but ang ako ang i-discuss lang sa inyo during our time no until December is gamay lang yun, portion lang yun siya. So the structure of mathematical knowledge begins to unravel itself when students take pure math subjects like abstract algebra, non-Euclidean geometry, but these courses are studied only by math majors. So as a result, the true structure of the true structure and nature of mathematics remain unknown to the larger segment of the society because very few lang jud, di ba? Anay uban students gani moingon nga ay dili ko mag take ani nga course kay daghan kaayog math. So most of the students you know or mga people ginaiwasan gyud nila ang math subject. So that is why gamay lang pud kaayo nga mga individual no ang nakaila kung unsa jud ni ang mathematics. So the nature of mathematics. So first, it is invented and discovered. So the concept of a number. So the beginning, mathematics na is partly invented. The beginning of mathematics is a human invention, and is nearly as old as the humanity itself. It began as a method to represent thoughts about quantity, form, pattern, and change. So the concept of a number, gani, for example, is an early manifestation of the concept of quantity, which gradually evolved into a primitive number system. So to distinguish no the ang isa ka cattle, distinguish siya from duha ka cattle, from 3 deer to 4 deer, ang isa ka crocodile from 10 crocodiles. So para kuan jud siya nato ba sana makita or ma-represent unsa ilahang kalahian. So prehistoric artifacts at least 20,000 years old discovered along the part of Nile River that runs through Congo show how why numbers may have been invented to quantify time. So this is the Ishango bone. So it is a fibula na of a baboon discovered in the area of Ishango near the Simliki River. So it contained, as you can see in the picture, it contained notches, kanang mga bagis-bagis. So it meant to track the lunar phases in relation to the menstrual cycle of women. So I have discussed this already, no? Unsa iyahang kuan, iyang pulos, unsa iyahang purpose ining Ishango bone in the early times. Next, the sophisticated numeration systems like the sexagesimal system of the Sumerians. So it was invented no of the people who lived in ancient Mesopotamia. So this invention goes way too far back in time. We can no longer trace the kinsaning mga specific nga mga tao no nga nag-introduce ani nga number system. So however, historians believe they were invented by the scribes who acted as priests, chroniclers, and administrators of huge human settlements for purposes of managing the irrigation, apportioning lands and taxes, and collecting taxes, counting livestock, kato nilang mga sa ilang agriculture, to para ma-manage nila ilang mga resources. And also in tracking the movements of the celestial bodies. So if the identity of the persons who invented early mathematics is vague at best, so we are quite certain about the identity of persons who invented recent numeration systems. For example, the modern binary system. No, kung wala ta kaila sa mga kinsay nag-introduce aning mga sinauna nga numerical system nato. So kani sa modern binary system, so it was invented or introduced by Gottfried Leibniz Boole. So, unsa man binary system? So, as you can see in the picture, it is a numeration system based only on 0 and 1. And all other quantities are tapos, it came to be the foundation of the binary logic due to the large part of George written uniquely as a sequence of zeros and ones. So, kaning logic na sa modern computers, it is based on the binary system. So, kung kinsay mga second courser dira or nag-eskwela og IT or sa inyong computer nga mga subjects, so, di ba, ang code lang or language nga ginagdawat sa computer is kaning binary system nga mga numbers, kaning 0 ug 1, coding. So, muna siya ang application niya. And, also, so, kani, na makabuang ni. Leibniz appeared prominently again in the connection with the birth of the calculus. So, he and Sir Isaac Newton are credited to have invented calculus or at least invented the early phase of calculus, no? May mga estudyante ka na mga kuan, anong giimbento pa maning calculus o yun sa may pulos ani. So Newton for his part invented the calculus to effectively measure rates of change over infinitely small intervals of time. So kumpara sa inyo ha or sa ubang tao nga usay pulosan ning calculus. So class, they invented this kay di ba mga tao sa una guan kayog physics. So ilahang gina-calculate ang time, ang distance, unsa iyahang rate of change sa time or sa other nga mga butang. So the rate of change or instantaneous rate of change is at the heart of the differential calculus. Next is much of the mathematics is discovered. So the initial impetus for mathematics was invention, but much of what followed next were discoveries. So kato kung mga ipang discuss kaganina, so they were invented now, but much of mathematics class were just discovered. So one of the early mathematical discoveries which had a huge impact in architecture and in the history of development of mathematics is the Pythagorean theorem. So nani siya sa inyong high school. So simply put, the theorem says that given a right triangle with legs A and B and the hypotenuse C, nariya sa picture, tanan niya, legs na siya ang A and B, and then kani is the hypotenuse, katong longest side no sa right triangle. So in equations, the sum of A squared and B squared is equal to C squared. So we look at the Pythagorean theorem as a relation between the three numbers, kaning A, B, and C. Ma'am, letter man ng A, B, and C. But last, it is a side, diba, sa right triangle. And kada siya nga side is na ay ginakuan nga distance. So, diba, ang distance is number. So, kana sila is nag-represent sa mga unknown nga numbers. So, si A, B, and C are all variables. So, now, as we look at the Pythagorean theorem, it shows no the relation between the three numbers, but ancient Egyptians and ancient Greeks look at them differently. So these squares pertain to actual squares as we understand them in geometry. So that is why na square dala nga tawagan na nga drawing. So people invented also no the early counting numbers. So, di ba, na to yung na-invented ng mga numbers, 1, 2, 3. But, as people, no, studied the numbers, so the succeeding propositions we have about prime numbers, the properties of numbers that arise from operations of numbers, the remainder, no, kung we divide a number by another, and many more. So, all these and all the properties contained in the body of mathematical knowledge that we know today, kato sila puros mga gi-discover na lang. So example kani mga commutative, associative, distributive. So di ba? Pag kuan sa commutative bisan pag unsa nga sitaw gani? Unsa nga position same lang kung for example 12 plus 5 is equal to 17. So same lang siya sa 5 plus 12. 17 lang gihapon. So kana siya discovered lang na siya nga kanang mga properties. So the foundation of mathematics was invented, but what followed next came by way of discovery. So dili ta makaingon nga tanan areas sa mathematics invented, tanan areas sa mathematics is discovered. Sagol sila class, complementary silang duha. So next is the plane geometry. So it is also called Euclidean geometry. It is a fitting example now of what we speak about as a body of mathematical knowledge. The part of geometry which is invented is the set of 5 axioms proposed by Euclid. So you can search na lang the internet no sa 5 axioms in Euclidean geometry. So the deliberate thought to begin mathematics by assuming these postulates to be true is an act of human invention. But the string of proven propositions called theorems spawned by these actions came to be discovered through logical reasoning. So na mga gipang propose si Euclid diri ang mga 5 axioms, but so kana siya is mga invented. But paano man nato siya nga ma-prove no nga true siya? So kana siya gistudihan and it was sa tawag gani it was defended or backed up by logical reasoning. So next, the nature of mathematics. So it is a language. Mathematics class is a form of language. So it is a symbol, or it is a collection of symbols, words, and syntax that convey mathematical ideas. However, math language possesses characteristics that make it similar to and different from other languages. So here are the characteristics of mathematics as a language. First, it is an ideograph. Meaning, ideographics, meaning it represents ideas, not sounds. So, bisan mathematics is a language class, kanang na mga symbols nga ginagamit nato, yang gina-represent is ang concept, ang idea, ang content, dili ang iyang sound, dili ang iyang the way sa iyang pag-pronounce. Also, another characteristic, it is non-temporal, meaning it doesn't change over time. Meaning, it is eternal, no? Permanent. And then, di ba, kung sa itong mga symbols sa una, maura gyapon ng mga symbols karon. Next, no emotional content but has aesthetic appeal or quality. So, sa mathematics class, dili siya naga-convey og mga emotions. Dili, di ba, pag magbasa ta og kuan, mga mathematical equation, wala man ta nagkuan dira nga, ay, nasuko ang narrator, ay, nakahilak ang kuan ani, ang nagbuhat ani nga equation. So, no emotional content. So, basta na mag-kuan po sa inyo dala magpilosopo. Ay, ma'am, kami ma'am nga mag-solve mo, ay makahilak. So, class characteristic of mathematics as a language, no emotional content. Also, last is, it is precise and concise, meaning, kung unsa nang gi-present dira nga mathematical equation or expression, so it expresses clear and efficient, meaning. So, mathematics or math language is an ideograph. So, these are examples, na kani mga Chinese characters. So, muna siya examples. To effectively describe, how math language came to be an ideograph or ideogram, or sa badaya ang other tawag. So, let us compare it with a language that is not an ideograph. So, let us compare it to a phonetic language like Tagalog, for example, or ang nadariya sa to picture is kaning Chinese. So, in mathematics language is an ideograph, phonetic language. So, ang words class, di ba? Pag naay tay ginabasa nga word, so it is symbolizes for ideas and sounds. So pag isulat nato siya, so di ba in English pag isulat nato siya, the way nato siya pagsulat mo, pwede the way nato siya pag istorya. For example, kaning tatay. So di ba kung unsay nakasulat mo, gyud ato ang pagbasa. But in mathematics class, the symbols represent ideas directly, not the sound. So, the meaning does not depend on the pronunciation. Diba? Sa English, kay kanang depende kung unsay tunada sa iyahang kuan. Nay same word, same spelling, pero different meaning. So, in mathematics class, kung unsa nang symbol dra, isa ra jud nakabuk iyahang meaning. So, it represent one idea lang. For example, kaning symbol, so it means the ratio of circumference to the diameter, or other word na itong ginatawag ani is the pi. Next, math language is non-temporal. So, normally, languages contain words that indicate actions. So, di ba, words that indicate actions, katong tawag ato kay mga verbs. So, actions either happen in the past, are happening in the present, or will happen in the future time. So, this produces a set of rules that affect the appearance of a word in relation to time. So, mo na siya sa English, di ba? So, na mga brag malahi na po diyan spelling, lahi ang pagka-pronounce, because nagaagad ta sa time. So, some languages, like the English and Filipino, have a conjugation of verbs to reflect the tenses of the verb. So, others, like Mandarin, modifies the tense of a verb by appending a time adverb or sentence particle. So, for example, sa English or Filipino, run, will run. So, kani sila tanan, di ba, is na-change ang symbol para sa dagan kay nagdepend siya sa time. But, in mathematics, statements are timeless truth and is not bound by time. Walay past, present, future sa math class. So example, 2 plus 2 equals 4. It is always true. Wala na past, present, ug future ana. So mo nang ginaingon nato perminti no. Sa mathematics class walay past is past. So kung unsa atong gi-discuss during elementary, high school, bisag karon college or hantod maniguang mo maora gyapon ang math. So, for example, kani, letter A, B, and C. So, you can pause the video no to read these examples. So, next, a math language carries no emotional content, but it has an aesthetic quality. So, it has no equivalent words no for joy, sadness, happiness, despair. However, how math language is used can inspire an aesthetic experience, a satisfying experience affected by logical coherence and form. So, in addition, the usefulness of math in many endeavors and how math ideas in one subdomain relate to other subdomains of knowledge add to this aesthetic appreciation. For example, so mo ni siya, symmetry in geometry. So, diba? Say tawag ani na sa patterns nga mga topic. So, di ba, in symmetry, balance. So, di ba, it conveys no an aesthetic quality. Another is, katong sa third year mo, di ba, na may proving. So, di ba, mas katanggap-tanggap kung ang inyong mga proof is short and concise kaysa sa taas kayo og explanation. So, that is an example of elegance of a short proof. Next, math language is precise and concise. So it is exact and accurate, and as a consequence, it has no need for unnecessary words. Direct to the point. So this, however, does not always help students because by being novice in math, they need elaboration, exploration, and more explanation, which can be achieved only with more speech. Diba sa math, kung unsay nakabutang maura gyud siya. So kung ikaw student kanang brag mag self-study lang ka. So brag dili jud kaayon nato siya masabtan no kung mag self-study lang kay kailangan pa siya i-explain sa atoa. So that speech, however, comes from teachers and writers who assist students in their studies and not from mathematics itself. So the language of teaching mathematics or the language of mathematics education is not the same as the language of mathematics. So the language of mathematics education class is necessarily redundant and replete with teaching strategies that must sacrifice precision when necessary. Third, so the nature of mathematics, it is a systematic body of knowledge built on abstract concepts and logical reasoning. So mathematics no, is a systematic body of knowledge, and there is a clear and distinct organization in the various subdomains of knowledge in mathematics that sets it apart from other intellectual disciplines. So the formal organization of mathematical knowledge in both academic textbooks and professional journals is essentially deductive. So organization is deductive. So it begins with mathematical objects, number 1, and their descriptions. It is followed by the definitions of relations among objects, and lastly, it is the collection of assertions or ang kanang ginatawag nato nga mga theorems that logically follows from one another. So the subdomain of mathematics that is under the category of pure mathematics, it requires a formal proof for all assertions. So the necessity of a formal mathematical proof permeates the entire body of mathematical knowledge. Fourth, so the nature of mathematics, it aims for what is true and beautiful. So mathematics is not value-free. It is laden with values. So it cares deeply for what is true and beautiful, although these aspirations are often implied only. So the entire process no, of doing math is chiefly aimed at discovering what is true using a set of fundamental principles and rules of reasoning. So, di ba, kaning in mathematics, ginagamit siya to prove something nga gina-claim sa science or sa physics. Or kaning unsay kaning mga ginakuan ni mga scientists, di ba, ang ilang ginagamit to prove their claims kay math. So, however, to pursue what is true is not enough. It must be accompanied by an aesthetic quality. So, nadiraning pasok ang beauty. So, it arises from elegant logic and form. Thus, how math language uses logic and form to achieve the truth affects the aesthetic quality of mathematics and the consequent emotional experience that comes with seeing something truly beautiful. So, emotional impact, no? Beauty in math can inspire awe and satisfaction. So, ambot lang, no? First lesson pa lang ta. Ambot lang kung na-inspire ba mo. So, next. So, lastly, mathematics, no? It possesses unmatched usefulness in the physical world. So, mathematics has an extraordinary effectiveness. So, according to the physicist, no, si Eugene Wigner, so, in an article published in the 1960s, he pointed out that the structure of a piece of physical reality rendered in mathematics language does not only satisfyingly model that reality, it also points to further advances in the theory and at times even to predictions. So, according to Eugene Wigner, math models reality accurately. So it also leads to new theories and predictions. So we need not visit the fundamental laws of physics, all of them rendered in math language, to see once again the extraordinary usefulness of mathematics. So everyday life, no, is replete with many applications of mathematics. So, nadira ang measurement in transactions, economics and business, in education naman, katong grading and qualification decisions, in health, the medical test measurements, and lastly in planning, no, kaning population projections and resource allocation. So what also na-discuss na nato ang nature of mathematics. So from those characteristics no or from those five natures of mathematics. So what is mathematics? So there is no single universal definition unsa ning definition gyud sa mathematics according to Tobis. So over history, many thinkers have proposed their own meanings. So according to Aristotle, so he saw it as the science of quantity. According to Auguste Comte, it is the science of indirect measurement and Peirce as a way of drawing necessary conclusions. And also, according to Russell, it is math is all about symbolic logic. And more recent definitions no emphasize the structure, the order and relation, and the application. So by Fraser and Yadav. So in our working definition, unsa ning mathematics? So for our purposes, we define mathematics as both a language and a body of knowledge. As a language, it names and describes the quantity, form, patterns, and change, and how they relate to another. As a body of knowledge, it is built from the concepts and relationships discovered and validated through logical reasoning. So the principal branches of mathematics no mo ni sila daghan kaayo. So it is organized into several principal branches, each focusing on the different abstract objects and their relationships. So different branches sa mathematics class lahi-lahi pud sila og ginastudihan or lahi-lahi pud sila og function. So in algebra no, they study set and the structures formed by operations on them. In analysis, they combined calculus and abstract algebra. Also, they explore the limits, derivatives, and integrals. And in combinatorics, it focuses in counting and the arrangement Sa geometry, kaning Euclidean and non-Euclidean, the properties of space, flat ba siya or curved nga space, so and so on. Di na ako na siya isa-isahon ka mo nalay basa. So it is important no that to note that statistics, although heavily mathematical siya because it studies physical reality and it is also similar to physics. So it is just it is not a principal branch of mathematics. It just studies physical reality, not abstract objects. So, kung makahuman mo mga math courses, mo graduate mo mga math courses here. So, here are your possible jobs, no? So, in academe, pwede mo mag-teach math courses. You can conduct and publish researches through CHED and DOST nga mga scholarships. Second, in industry, they work in the areas such as data analytics, finance, consulting, napadarang artificial intelligence, and digital commerce. Next, the third is the banking and finance. So mathematics graduates play key roles in business analytics, a field essential to all banks and financial institutions. And lastly, professional teaching. So it offers opportunities not to teach in primary and secondary schools, provided one has the necessary license or completes the required education units. So for example, sa BTVTED or SACWA, BS Ed Math, so that is an education subject. So para makatudlo jud ko no nga credible ko magtudlo, kailangan po jud magkuha og license. So this path show that mathematics is not just theoretical, but it opened doors no, to both academic and highly practical careers. So that is all for the first lesson. So balik ta sa ato ang objectives. So again, tanaw na to kung na-achieve ba na to ang atong objectives. So yes, we have described the nature of mathematics and we differentiated no unsa ning invented or discovered nga mathematical concepts, and also we have discussed also the practical uses of mathematics no in real life context. So if you have further questions, you may comment since i-upload naman ni sa YouTube. So you may comment down on sa inyong mga questions or mga clarifications about this lesson. So that would be all, class. Thank you and goodbye.